Okay, well, let's see what we can do with section 4.4, derivatives of other trigonometric functions. It's derivative of other trig functions because we already know two, don't we? Sine and cosine. We know how to take the derivatives of those. So we want to find the derivatives of functions that involve trig functions, and we'll use our sine and cosine to help us. It's a good thing that we know those. So let's get going, see what we can find out. Okay, remember that the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. We want to use that reminder, and one of our new rules to find the derivative of tangent x or cotangent x. And when I say new rules, what should pop into your mind from yesterday and the day before? Maybe today and yesterday? Anyway, it should be the product rule and the quotient rule, right? Okay, so let's see what we can find out here. I'm going to do the derivative of tangent x, and then I want you to pause it and do the derivative of cotangent x. So if I let y equals 10x, and I tell you that I want you to think of that and look at that and take your derivative. You can't do it right now. But when I put that little clue in there about use one of our new rules, that means that you need to go in and think about your identities. What is tangent x in terms of my identities? You should be thinking sine x over cosine x. Again, oh my goodness, y'all, please be patient as I am trying to do these things with my pinky. We are hoping that the stylus gets in and everything is in better shape very shortly. Okay, so sine x over cosine x. Okay, so therefore what that means is that y prime is going to equal, and obviously from looking at that right there, that is a quotient. We're going to use our quotient rule. So stop and think for just a second. Get that formulated in your mind. Quotient rule is the bottom times the derivative of the top. Derivative of sine is cosine. Minus, big time. You got to remember that the minus goes on the quotient rule. The top times the derivative of the bottom, which is a negative sine x. And then don't forget that all of that is over your bottom squared. Please forgive the extra little boxes. I'm not sure what that is, but I don't know how to fix it with my pinky. Okay, so then I have, when you simplify that, cosine squared x plus sine squared x. For some reason, when I'm making those little x's, it seems that it wants to drag. I'll try to be more careful. All over cosine squared. Well, cosine squared plus sine squared is 1. Hopefully we remember that identity. 1 over cosine squared. And we have another identity right there that should be showing up. 1 over cosine squared is secant squared x. Hopefully we remember that from our trig pre-cal days. All right, so not very easy to read on that, but the derivative of tangent x, y prime, is going to equal, I was going to try to write it so you could see a little bit better, but maybe not, secant squared x. So the derivative of tangent is secant squared x. Go for it with cotangent, see what you get, hit the pause button, and then we'll pick it back up in a minute. Okay, let's look at secant and cosecant. If I say y equals secant x, then again, I've got to go back and think through, okay, what does that really mean? Well, that means to rewrite that, that's 1 over cosine x. But what that is cosine x to the negative 1 power. Okay? So your y prime, then, when you take the derivative of cosine x to the negative 1, all you're going to do is do your power rule. So that's negative 1 times cosine x to the negative 2. Okay, power rule, negative 1 times cosine x to the negative 2. But hopefully you didn't forget, when you've got something like this, you also have to do the chain rule. So by the chain rule, the derivative of cosine, that inside function there is a negative sine x. Okay, so that's going to equal, I've got my negative 1 times the negative sine x. That's going to give me a positive sine x on the top over my cosine squared x, which is going to split to sine x over cosine x times 1 over cosine x. And so I see ultimately here that my y prime function, excuse me just one moment. All right, my y prime function is going to be tan x, and then the 1 over cosine just does change to secant x. Now I'll be real honest with you, if you look in any book, it's not going to say tan x secant x, it's going to say the derivative of secant is secant tan. It kind of helps your memory to tie those two things together. So know that whenever you're finding the derivative of this, the derivative of secant is secant tangent, secant x tangent x. I want you to pause it for a minute and find your cosecant function, find the derivative of that. And I want you to notice on these that the ones that you've been finding have both turned out negative. Why is that? What is it on those that makes those turn out negative? All right, hopefully you're back with me. You've paused it and got those figured out. So what I want you to look at here then is a basic summary. If f of x is sine x, then f prime is cosine. If f is cosine, then f prime is negative sine. If f of x is tangent x, then f prime of x is secant squared x, and so on down the way. Now if you noticed, every other one on the right hand side is negative. So look back over on the left hand side and see if you can figure out what is causing that. If I look at that, I see that here at cosine x, and at cotangent x, and at cosecant x, on all three of those, my derivatives are negative. If you notice, they all start with cosine, cotangent, cosecant. Every co-function like that is going to have a negative derivative. So jot that down, star, highlight, store it in your memory, whatever you need to do, but make sure you know that the derivative of a co-function is always going to be negative. Okay, let's get some practice problems going. We'll do the first one here. F of x is tan to the 5th of 4x. I'm going to rewrite that as f of x equals tan 4x to the 5th. Again, I'm so sorry about the extra boxes. I have no explanation for those. So f prime of x is going to be, first of all, a basic power rule, 5 times tan 4x Okay, that's a pitiful 4. Okay, that's a little bit better. 5 tan 4x. And for some reason it decided to stop writing. To the 4th. And then your derivative of tangent is secant squared. I'm going to go down on the next line because I'm kind of out of room here. So times secant squared. Because by the chain rule, I got to take that derivative. And then times 4. Okay, so we had to do our chain rule twice on that because I had the inside function of tangent and then the inside function of 4x. So I had to take the derivative of each one of those. So I see overall on this one, my derivative is going to be, I've got a 5 out in front and a 4 there, so that's going to be 20. And tan to the 4th of 4x and secant squared of 4x. Okay, again, not sure why things move like that. Please be patient with me. Okay, so there's your solution on that one. Not a big deal. Looking at this next one, problem number 2, you have y equals secant x times cosecant x. The thing that should jump out at you right there is, it's product rule. Okay, don't just take the derivative of each one and call it good. We've got to go through and think through our product rules. So we're going to have first times the derivative of the second plus the second times the derivative of the first. So I have y equals, or y prime, excuse me. It's going to equal the first secant x times the derivative of the second. Derivative of cosecant is negative cosecant x cotangent x. Okay. This is really frustrating me. So hopefully it's not so bad on y'all, but I'm trying to be patient here. Okay, y prime is secant x times negative cosecant x cotangent x plus, taking derivatives again, that was first times the derivative of the second, so we went with the second cosecant x times the derivative of the first, and the derivative of secant is secant x tangent, and there it goes again, tangent x. Okay, so that's going to equal, when I look at that, I have a negative secant times cosecant times cotangent and a positive cosecant and secant and times tangent x. Okay, I paused it for a minute there just so I could regain my level of frustration from trying to do this and get things to show up. So hopefully that last little bit made sense and connected fairly well. It may or may not have. Okay, this is where I am. I've tried to remove things back a little bit so that they look a little bit better. On this one right here, there's not a whole lot else that you could do. You could factor out secant and cosecant from this, but it doesn't really help you at all. The one thing that I would do on this is I would write my cosecant times secant times tangent first since it's positive, and then subtract the upper one. So that's what we're going to do, or at least make an attempt to do at the moment. So let me get my pen. And I've got cosecant x, secant x, tangent x. Okay, which could simplify at that point because the cosecant could cancel if I rewrote it as 1 over sine and tangent is sine over cosine, then I could get a couple of things to cancel, but it's not going to be that beneficial. I'd still end up with squares in my denominator. So we'll do that minus secant x times cosecant x times cotangent x. And hopefully we're good on these two problems that we have done. We'll do one more, and then I will, we've got, I think, 3 more left, but I'm going to do one more with you, and then I want y'all to try the last ones on your own. See what you can come up with, and we'll start those as warm-ups tomorrow in class. Okay, so here we've got f of x equals 5 natural log 7x over cotangent of 14x. So again, we're going to try to get this as carefully and as quickly as I can. If not, y'all be patient, and we may work all 4 of these or whatever we have left in class tomorrow. So f, oh, of course, we need to grab our pen. Not sure why it doesn't stay with me from one page to the next, but so we have f prime of x equals the bottom, cotangent 14x, and okay, pen one more time. We'll try anyway. No, it doesn't want to work. Let's try cotangent. There it is, of 14x. All right, sweet kiddos. So I'm looking at this, and I've got cotangent x, that's the bottom, times the derivative of the top. My 5 is a constant, so it stays right there. Derivative of natural log 7x is 1 over 7x, and then by the chain rule times 7. I have put that over that denominator squared because I do not have enough room. We're fixing to do, that's bottom times the derivative of the top. We're fixing to subtract and do our top minus the derivative of the bottom as well. So minus the top times the derivative of the bottom. Derivative of cotangent is, do we know? Negative cosecant squared x, hopefully. Y'all know that. And again, that is over your cotangent squared, 14x. Okay, so that is bottom, cotangent 14x times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. If you look at your first ones, the 7s should end up canceling out. So we will mark those out. And so that's going to give me a 5 times a 1 over x times cotangent of 14x. This one may take us me adding one more page to be able to get this whole thing in. So currently I've got a 5 over x cotangent 14x. And then it's minus, but there's also the negative from the cosecant squared. So we're going to do plus 5 natural log 7x. I'm hoping that that L does not look too much like a 1. Of course, who knows with all these extra boxes suddenly showing up. 7x cosecant squared x. All of that over cotangent squared 14x. Hopefully you can read that now. Not sure where the boxes decide to come and go, etc. All right. Now then, my problem with that right there, and I'm going to add a box and then see if, or add a page, excuse me, see if we can finish this real quickly. And remember, the problem with that right there is that I cannot have a fraction within a fraction. So I need to multiply all the way through the top and the bottom by x in order to get rid of that. So that's going to give me, as I do this, equals, that's going to become a 5 cotangent 14x. And plus, when I distribute the x that I multiply by through to this, I get plus 5x natural log x, or natural log 7x, excuse me, and then cosecant squared x. And hopefully this will all fit. Hold your breath. Yay! All over on the bottom. Cotangent squared 14x, but remember we multiplied top and bottom by the x to get rid of it there. So that makes this x cotangent squared 14x. Okay, so there is your solution on that one. That x that was in that first term, we had to multiply all the way through, so it gave us an extra x in the second term on the top, and it gave us the extra x in the denominator. Hopefully we are good. We will try that y equals tan of sine 3x problem tomorrow. Although you're fixing to see it show up, we are not going to do it right now. And then we will also do that second derivative of y equals secant x. Try those two. Somebody come in ready to show me what you know and questions and all of that type of thing, and we will get going on this tomorrow. Again, I'm sorry for all the little extra boxes and the delays and the movements. I have no explanation for that, and it was incredibly frustrating to me, but after 20 minutes of recording, I was not going to stop and redo it. So hopefully we will get better at these things, and if not, then we'll just go back to the way things were. Thank y'all very much for being my kiddos and for listening. Bye, y'all.